in terms of vibration, vibrating that screen, we couldn't get the sample down into the oven until something miraculously on Sol 16 happened, something released in the material, and it all dropped down into the TEGA. But unfortunately, we had waited, it had sat and baked out in the sun so long that all the interesting stuff, all the volatiles, had already been driven off of the material. So it was actually a pretty uninteresting sample once they started cooking it. So while all that was going on with the TEGA, while the TEGA kept trying to shake this sample and get material into its oven, we kept digging with a robotic arm. And this is an image from Sol 14. This shows two of the trenches that we've dug. This is called the Goldilocks Trench Complex. And you can see again, we didn't have to dig very far, just 3 or 4 inches below the surface here, and you start seeing this high albedo, highly reflective, white-looking material. Looked really promising. Okay, this picture is a little bit of a detour. It doesn't have anything to do with the water story, but I just had to show it because it's one of my favorite images from the mission. It's kind of an iconic image. And it was taken by complete accident. This image wasn't supposed to exist. This image was supposed to be a part of the mission success panorama, which was one of our minimum success criteria for the mission, was that you have to generate a full color panorama of the scene that minimizes the amount of spacecraft hardware in the panorama. And so this had been planned out to be just an image of the landscape. And either the robotic arm was in the wrong place at the wrong time, or the SSI took the wrong picture at the wrong time. But I think it's just a beautiful shot. It shows, the scoop, it shows a robotic arm, it shows a robotic arm camera. You can even see some material in the scoop here. And so this was intended to be a part of that mission success panorama. We actually started to call the mission success panorama Peter's Pan, after Peter Smith and after the fairy tale character. So that's the name we. Anyway, back to the water story. So this Goldilocks Trench Complex, we continued to dig in it and actually extended it and made it into one big trench, which is shown right here. This is how it looked on Sol 20. So on Sol 20, we decided to stop working on that trench. It was, that trench wasn't all that interesting, we thought. It was sort of a first test trench to see how we were doing, how we could dig into the surface. And we decided to leave it alone while we went off and did other things. But we continued to monitor it. We continued to take pictures of it using the SSI. And what happened on Sol 24 is we noticed that these 3 chunks of material right here, which were about the size of dice, had actually disappeared. And so this was really the smoking gun, that all this white stuff we were seeing was in fact water ice, the stuff we had come all that way to study. And in fact, it was kind of interesting because there were some geochemistry team members who were actually starting to build arguments that a lot of this white stuff we were seeing was actually salt, because according to some calculations, the white material was being a lot more stable than what you would think water ice might be. But the fact that it disappeared said, nope, it's actually not salt, it is water ice. There was a big press conference, and fortunately, we could stop calling it these really tortured names like high albedo, highly smooth material, highly reflective material. We finally said, yeah, this is water ice. And there was a big press conference, and it was a great day for the mission. Every time we had an opportunity, when we weren't doing digging or we weren't doing delivery samples to the in situ instruments, we would go back and take pictures underneath the lander of Snow White, or Snow Queen, and Holy Cow. And we started to see some interesting things happening on this lander struts, which are these right here. We started to call these features on here barnacles. Now I'm going to show you more about that in a little bit. It actually took us a long time before we saw any changes in Snow Queen. We didn't see any changes in Snow Queen until Sol 39, which again was kind of the smoking gun that, yeah, that was really a water ice feature. Then at this point in the mission, around Sol 20 or so, there was a point where we decided, well, what should we do? Should we try to get that really first good TEGA sample from that trench that we've already dug, the Goldilocks Trench Complex, or dig a new trench? And the team was kind of split in half, but Peter Smith was on the side of the team, or in the group, that said, let's go and build or dig a new trench. And so this was the new trench that we started. This was the Snow White trench right here. This is how it looked on Sol 43. We had started it on Sol 22. But this trench was a lot harder to dig, and in retrospect, we probably should have taken our first TEGA sample out of that Dodo Goldilocks trench. Because what happened is we hit a hard ice layer pretty quickly, and you can actually see that here. You can see the chatter marks on the bottom of the trench floor right here. So the robotic arm hit this hard layer and kind of skipped across it. And the robotic arm guy said this had a consistency of close to cement. So this is really difficult to dig into. So we spent a lot of time trying to get a sample out of Snow White Trench. This is, in fact, you can see, this is a true color image. This is a false color image that brings out the ice features a little bit more. But these are little areas where we tried to use that rasp and dig up material to try to get some samples into the scoop. So we did that. We tried that a lot. We would work in this trench. We would dig. We would rasp a little bit, try to get something into the scoop, and then we would deliver it to the TEGA completely blind, because we didn't want to have the same thing happen that happened with that baby bear sample, the first sample that we delivered to the TEGA, where all the interesting stuff is just driven off out of the sample while we wait to look at the image and decide what we're going to do. So we decided to try and dig and deliver in a blind state. And we had to do that a lot. It took a lot of practice. On Sol 60, we came completely empty. So here's the TEGA door, again, open on this side, but no sample was delivered. But finally, after a lot of practice, on Sol 64, TEGA, we finally delivered a sample to TEGA, and sure enough, we started to bake it, and we saw the water ice signature. So this is the signal from the calorimeter oven. So this is the amount of power that the ovens are putting in as a function of time. And right here around 0 degrees C, where you would expect water to be driven off, you see that we had to pump in a lot more power to keep the temperature ramp being constant. And then also, once that vapor was driven off, it went to the mass spectrometer, and this is the mass spectrometer trace as well, showing that we got a signal in the H2O channel. So this was a big deal. This was kind of the raw data. I don't know if you'll see this published anywhere, but this was the data that we worked with when it was actually discovered. And a big press conference was called, and reporters were called in, and we said, Phoenix has discovered water ice. And they were kind of underwhelmed because they said, didn't you tell us that on Sol 24? And in fact, we had, but getting a sample into the TEGA and proving it was water was one of the mission requirements. So it still was an exciting day for the TEGA team. As the mission wore on, we started to see water, actually condense onto the surface. So that's what's shown there. And again, I'm kind of running out of time here, but I did want to show you this cohesiveness of the soil again. And this was really unexpected. We didn't expect the material to be almost clay-like, where it's just holding itself together. And you can see on Sol, what was happening here, a picture from the rack shows material kind of falling out. Here's the sample on Sol 35, and then on Sol 36, in between that time, we didn't do anything. We didn't move the robotic arm. We didn't remove the scoop at all, but material starts raining out of it. So again, stuff starts to get driven off out of the soil, and then the soil starts to release, just like we saw with that first TEGA sample. Okay, now I do want to show you, I've got to take the time for this. It's a sort of controversial result or measurement that we made from Phoenix, and we think we may have seen liquid water in action on Mars. And as many of you may know, liquid water, because of its triple point, actually can exist. At least pure water shouldn't be able to exist on the Martian surface. But if that water is mixed with some kind of salt, or you have some kind of brine solution, it changes the triple point to the point where you could actually have liquid water. And this was actually predicted by Haberle back in 2001, which we weren't aware of until we started making these observations and did a literature search. And actually, it had been theoretically predicted that you might see this in certain places on Mars. So I'm going to show you a little animation here, and you can kind of judge for yourselves. So these are rack images, again, underneath the lander. And what you want to look at is the material that's located on the strut, these barnacles, in particular these two particles. So first, the animation goes through just discrete images showing you how the particles changed over time. So what it looks like is happening is that globule actually merges with this other globule, and then you actually get one big drop of something. At least that's the interpretation. This next round of images shows you interpolations between the images. It's a little more convincing, at least to some folks. So the idea here is that this is actually liquid water that's sucking up more moisture out of the atmosphere over time, and then the particle grows, and you actually, if you look at some of these other particles, it seems like they actually disappear and fall off the